our situation that we have here, our scenario. We are at a school dance and we're helping to clean up after the dance is over by collecting different soda cans that are comprised of Coke and Sprite. Some of the cans are located on a table, some of the cans are located on the floor. We have 72 total cans that were found. 42 cans were on the floor, 50 cans were Coke, 14 Sprite cans were found on the table. Okay, so let's go ahead and figure out where to place these numbers. So let's start with the value of 72. 72 total cans were found. Where is that going to go on our table? Which placement is it going to go, Jair? Number 9. It's a total, right? 72 total. It doesn't say total Coke or total Sprite or total floor or total table. It just says total. So that means it represents the total. Okay, so 72 is going to be located in box 9. Let's go ahead and talk about the 42 cans that were on the floor. Where is that going to be located? Amy? Huh? The 42 cans that were located on the floor. Good. Yeah, that's the total amount that were on the floor, which is going to be in 6. So we're going to put 42 here. Okay. Then we've got the 50 cans of Coke. 50 cans of Coke is going to be located where, Bonnie? Number 7. Good. So 50 cans is a total, so it is going to be on the total Coke. Because it doesn't say 50 floor or 50 table, just 50 cans of Coke. Okay, so that has to be comprised for the total. And then our last one is going to be 14 Sprite cans that were found on the table. 14 Sprite cans found on the table is going to be located where, Leland? Huh? 2. Okay, so we're going to put 14 here. All right, so then for the rest of it, we're just going to have to do some logical reasoning in mathematics. We obviously know that we can take 72 and subtract 42 to be able to get the value that goes here, which is 30. Now that we know that this is 30, we can always do 30 and subtract 14 to be able to get this value being 16. Okay, knowing that this is 50 and this is 16, we can go ahead and do 50 minus that 16, and that's going to give us 34 for number 4. We could do 72 minus the 50. That's going to give us 22 for box 8. And we could either do 22 minus 14, or we could do 42 minus the 34. It does not matter which one you do. You're going to get 8. Okay, everybody clear so far? All right, so now let's go ahead and look at question number 10. Question number 10 says, what is the relative frequency of Coke on the floor to just Coke? So how much Coke is on the floor? So I'm going to put Coke, floor. How much Coke is on the floor, guys? 34. So 34 is going to be the value that goes on top. And we're going to compare that to Coke. Doesn't say anything else about Coke, so it's just consumed or considered to be Coke's total, which is what? 50. So we have 34 over 50. Now 34 over 50 can be simplified. It's going to be simplified to 17 over 25. Okay, if we were to convert that into a decimal, you would just take 17 and divide it by the 25, and that would come out to exactly 0.68. And if you wanted to change that into a percentage, you could just multiply it by 100, and that would be 68%. Okay, let's take a look at problem 11. The relative frequency of Sprite on the table compared to Coke on the floor. So we're going to focus on Sprite table. How much Sprite table is there? How much Sprite is on the table? 14. And then we're going to compare that to Coke on the floor. So we're going to put Coke, floor. How much Coke is on the floor? 34. Okay, so we have 14 compared to 34. That can be simplified. Simplifies down to 7 over 17. When we do 7 divided by 17, we are going to get an irrational value. It's going to keep going with no rhyme or reason. But we're going to go ahead and estimate it. So I'm actually not going to put equals. I'm going to put an estimate. It's estimated, or approximately, 0.41, because it's like 0.411 something. And then when we multiply that by 100, again, it's approximately, 40 41.1%. Okay, any questions? All right, so scatter plots, that's what we're going to be discussing today. We're going to be discussing the different kinds of associations that are created with scatter plots and what a scatter plot looks like when it's plotted. And then after we're done with our notes, you'll do a couple of quick IXL skills that do need to be completed before the end of the day tomorrow. So they will be loaded up on Google Classroom, and they need to be completed fully before the end of the day tomorrow. All right, so let's talk about the different types of variable associations. Okay, associations, when we talk about associations, another word for associations would be correlations. So I'm going to put correlations in here. How it affects each other. The cause and effect. So you guys learned about cause and effect in social studies, right? When something happens, it has an effect on another event. So if a president is assassinated, it has an effect on the country. Okay, it might cause a war against another country. So for example, something you guys never experienced, but there was a war that was going on between different countries back in the early 2000s, late 1990s, early 2000s, and the United States kind of stayed out of it until a big event happened that caused us to get involved. Anybody know what that big event was? 9/11. So when 9/11 happened, when all those planes crashed into the different buildings, into the Pentagon and the Twin Towers, that caused our country to decide to step in and go into war. Okay, so that had an effect. Same thing when we're talking about scatter plots. We're focusing on two values, two separate quantities or qualities. It's really the better word to use. Quantities is more an effect of numbers. Qualities is an effect of like a relation. Okay, when you're looking at two different situations, if they have any kind of effect, like whether it's a positive or a negative effect on each other. Okay, and don't think of negative as a bad thing. There are times when a negative correlation is a very good thing to have. For example, if I wash my hands a whole lot, what is that going to decrease the likelihood of? Germs, right? It decreases germs. Germs are bad. Getting sick is bad. So the more I'm washing my hands, it has a negative effect on germs. It causes the germs to go down and the effect that I might get sick. That's called a negative correlation. So I don't want you guys thinking that when you see a bad event that means it must be negative. It's not necessarily true. Positive and negative don't mean good or bad. They just mean the effect that's happening. Okay? So positive association, when we're talking about a positive association or a positive correlation, a positive effect, it looks somewhat like the following. Now I'll do this in green. You have a coordinate system, and then your scatter plot. Think of the word scattered. If you see the word scattered, does it mean it's going to go in a straight line? No, they're not going to be linear, but it's going to follow somewhat of a trend that's happening. And it looks almost like if you could draw a line to relate it, which would be called a line of best fit, it would go in what we would call a positive direction, kind of like slope. Think of slope. If this were to be a really, really fat line, that I'm having a line going this way, it was going to create this positive slope. So positive association is the same thing. The positive means that as your x is going up, as your x is increasing, your y value is also increasing. Or another way to look at it, as your x goes down, so if I'm going backwards on my x, going down, then your y value is also going to go down. So they have the exact same identical effect. That's what causes it to be a positive association. Okay, then we've got what's called a negative association. Or negative correlation. And that's going to have the opposite effect. So when we're looking at it, if we could think of it as a line, it's going to look almost like a negative slope, where it's going to start, when it's at the beginning of its x values, it's going to start higher up on the y. And it's going to start following a trend that's decreasing. Okay, this is going to be our negative association. So as x increases, it has the opposite effect on y. The y is going to go ahead and decrease. Or as your x decreases, your y would increase. And then, of course, we have what's called no association whatsoever, because not everything is related to each other. So for no association, that means that you wouldn't be able to find any kind of trend. It literally would have plots that are all over the place. You wouldn't be able to create a positive line or a negative line. So I have a point here, 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 and it's just kind of all over. That would be no association, no effect. So these are called variable associations. They're showing the effect that's happening when we're looking at a comparison of our x's to our y values. You also have what's called a linear association. So remember when we talked about linear is a representation of a line. If your scatter plot has a linear association, it means it somewhat looks like it's following a straight trend. Then nonlinear makes it look like the scatter plot has some curvature to it. Okay, so let's go ahead and take a look at a couple examples of that. All right, linear associations. When we're talking about linear, it looks almost as if the scatter plot could form a very straight line to it. Okay, that would be a positive linear relationship. This would be a negative linear relationship. Then you have what's considered to be the nonlinear. So nonlinear means it's going to have curve to it. But you can still have nonlinear, positive nonlinear, and negative nonlinear relationships as well. Okay, so here's going to be an example of a positive nonlinear. Where it has a curve that's going against it. And then a negative nonlinear. So if it looks like it has any kind of curving that's happening, then that is going to be nonlinear. Okay, now you're not always going to be looking at the graphs and being able to identify whether it's a positive or negative or no correlation relationship. Sometimes you actually might be given the situation or a scenario and you're having to decide, is that going to create a positive or a negative effect? So let's go ahead and talk about some different positive correlations, some examples of positive correlations. So one positive correlation is the idea of studying. So the time that you would spend studying for an exam or studying for a test versus the scores that you possibly would receive. Okay, now as we know, there are always those exceptions of people who might not study much and they do just fine, or people who study a whole lot and still don't do very well. But for the majority, this is what you're trying to think of, for the majority of people, if they spend more time studying, their scores are going to potentially be higher than those who spend less time studying. Okay, so that's what we're going to write down here. If you have a low amount of time, you have the potential of having a low score, versus if you have a large amount of time, probably going to have a higher score. And that's one of the things that, you have to try telling yourself, oh, I didn't study and I still got like a B. But if you had studied, would you maybe have gotten a better grade? Maybe you would have gotten an A. Or, oh, I didn't study and I got like a 90. Yay, I got an A. But if you studied, maybe you would have gotten a 100, right? You're having to think of those things. Okay. The years, as the years are passing in relation to the gas prices. Okay, long time ago, say like in 1970, gas prices might have been around 62 cents a gallon. I remember one time when I was in high school and it was a wonderful, wonderful week where gas was 89 cents. That had never happened before. Gas was always over $1. But in this one week in high school, I remember, oh my God, I got to get my tank filled up because it was only 89 cents or 88 cents. And it was like a marvelous, wonderful thing. Okay. And that wasn't in the 70s. That was in the 1990s, late 1990s. So if you're thinking about now, here in 2022, currently, I just filled my tank up for $3.89 a gallon. Gas goes up. Maybe not every single year, but throughout a period of certain years, the gas prices is going to increase. Okay, we'll do one more off to the side. A child's age versus their weight. A child's age versus the weight. Okay, when a child is really, really young, like as a baby, they're going to have a lower weight, right? When you're born, you weigh less than 10 pounds for the majority of people. But as you get older, your weight starts to increase. You start getting into, the 10, 15, 20, 25, 30, whatever, how many pounds until you're at your age where you're probably in your anywhere between 80 pounds to 120 or 130 pounds for some people. Okay? So the older you get, the more you start to weigh until eventually you hope that it caps off. Okay, so these are all positive effects. That when the X is low, the Y is low. When the X is high, the Y is high. Okay, so it has a positive correlation to each other. Get that written down, then we're going to go to talking about negative correlations. So having some negative correlations. Like I said before, the idea of washing your hands and germs, right? Sickness, germs. So the more times that you wash your hands, the less germs you're going to have, right? The more that you wash, the less germs. So when X is increasing, your Y is decreasing. When your X is a high value, your Y is a low value. And in the reverse, if my X is a low value, if I don't wash my hands very often, especially during cold and flu season, then I'm increasing the amount of germs that I potentially am going to carry around. I increase the chances that I might get sick or that I might spread sickness. Okay, food temperature. Versus the time that it's spent on the table. Okay? So think about it. If our food is nice and piping hot, a really hot temperature, and you have to blow on it to be able to eat it, how long do you think it's spent on the table? A couple minutes maybe? Maybe the food just got onto the table, so it's got a very small amount of time. Right? Less time on table means the food's going to be hot. But if you're sitting around and you're talking, you're enjoying your meal, you're having a conversation with your family or with your friends, so you're spending a lot of time with the food sitting at the table, what happens to the temperature of the food? It goes down, right? It gets cooler, becomes easier to eat. You know, if you have a big old bowl of pho in front of you, when you're first starting to eat it, it's really, really hot. But if you're sitting there and you're talking for a while, eventually it gets to the point where you can eat it without having to blow on it anymore. Okay? It is very low temperature the longer that it goes. Same thing if let's say that you have ice cream. You get ice cream, it's a really, really, really low temperature. Okay, the more time that it spins, it changes, it has an effect on it, right? All right. Let's talk about, here, let's put that down. When it starts to get to a low temperature, that's more time that's on the table. All right, one more. Hair length. When you have long hair compared to the shampoo that's in the bottle. So let's see here. Let's compare how long shampoo bottles are going to last for Leo versus me before I cut all my hair off. When I had really, really, really long hair. Whose shampoo is going to last longer, Leo's or mine? Leo's, right? He has less hair, therefore he doesn't have to use as much. He might be able to use like a little dime size of shampoo in his palm of his hand, rub together, shampoo his head. Done. Mine, I might have to use a whole handful of shampoo to wash my hair. Okay, so it's going to, you know, go quicker. The shampoo bottle is not going to have as much in it compared to what Leo's might have. So the more hair that you have, and I know that this might seem like a really weird example, but I've seen the county use really weird extreme examples, so I'm trying to think of as many weird extreme things as I possibly can. But the more hair that you have, the less shampoo that's left. The less shampoo left in the bottle. Okay? The less hair you have, the more shampoo that is remaining in the bottle. All right. And then things that have no association whatsoever, meaning that they're not going to have any kind of effect. So the length of your arms to the amount of points that you're going to score on your test. Does the length of your arm dictate how you're going to do on your test? No, unless it's a stretching test. But it has no effect whatsoever, okay? So arm length versus test grade has absolutely no effect. Let's go with amount of hair versus food consumed. If I have really, really long hair, does that mean I'm going to consume more food? If I have really, really short hair, does it mean I'm going to consume more food? No. Your hair length has absolutely no effect on the amount of food that you're going to eat each day. If it did, then everybody would be getting their hair cut to lose weight. Okay? Has no effect. So things that have absolutely no potential effect on each other, those would be the no associations. Okay, what you're going to be doing is you're going to grab your computers and you're going to be getting on to do your SMART score of a 70 for the 3 IXL skills that are posted.